This is section 2.3 notes. And we're going to start out with systems of equations. So again, we're still in lines in this chapter. You've done this before in Algebra 2, so we will not do this like Algebra 2. We will not be using the substitution or elimination method. We're going to use our graphing calculator, so be sure you don't do those two methods. I know that in the book the answers show those methods, but we are doing it differently than the book. You can still get your answers from the book, but your work would have to be like I'm showing you right now in the notes. So types of lines and solutions. So these types of lines are called intersecting lines. Nothing new, I hope. And the solution is an ordered pair wherever they intersect. That is a point. This point here works on the blue equation and the red equation. So it's a solution for both. These lines are parallel lines. And parallel lines have no solution. By the way, these have one solution. And parallel lines, just for informational sake, are have the same slope. It just hops every time I do that. There we go. Same slopes. Different y-intercepts. And lastly, these two lines are right on top of each other, and those are called coinciding lines. And they have infinitely many solutions. And when I say infinitely many, so if I were to pick a point on both lines, it would be an infinitely many, and it would keep going. But if I were to pick, it's not all real numbers, because if I were to pick a point over here, if it was all real numbers, that point would work, and it doesn't. Or a point up here, that point doesn't work either. So it's not all real numbers, so make sure you don't make that mistake on the test. We also know that these have the same slope and same y-intercept. So those are the three possibilities when you're dealing with two lines. Okay, so let's take a look at this profit problem. A company is said to break even from the production and sale of a product if the total revenue equals the total cost. That is, if the revenue equals the cost, this equation right here. That would be breaking even. What does that mean? Revenue means money in. So even though you might make $1 million in revenue, that doesn't mean you make $1 million, because you're going to have cost. So cost is money out. And your profit is going to be, this equation right here, is when you take your money in and you subtract your costs. So if I made $1 million, but I had $500 worth of expenses like material, like paying my employees, like heat, like electricity, all that cost comes out. So then my profit is really only $500,000. Taxes would be a cost. So profit is really what you're making on it. So the company also breaks even if the profit for the product is zero. So if these are the same, it would make sense that if my revenue, if I took in checks from companies that I worked for, if it was $500,000, but my costs were $500,000, my profit would be zero. And that would make sense. So really understand that equation as we move forward. So suppose a company has its total revenue for a product given by that equation right there, and its total cost given by that equation right there, where X is the number of thousands of tons of product that are produced and sold each year. So depending on how much I produce and sell will determine what my X is, which would then determine my revenue with that formula and my cost with that formula. The company is said to break even when the total revenue equals the total cost, which is right here. Find the number of thousands of tons of product that gives break even and how much the revenue and costs are at the levels of that production. So we want to know where the revenue equals the cost. That's what we want to find out. So I'm going to take my revenue equation, I'm going to drop it in there, and my cost equation, I'm going to drop it right there. So again, this is the work I'm showing. And then we're not going to solve this algebraically. We're going to say this is y1, and I will tell you on the test what you're looking for. So if there's a place that has a graph on it on the test and it says use your graphing calculator, you know you're not going to be algebraically solving it. And I will be really clear on that, which ones are algebraically and which ones aren't. And this is going to be my y2. So you're going to go ahead and put those in your equation. And what's going to happen, and I want you to do this, don't be lazy right now because you're going to struggle on the test and you're not going to have time to finish it because you're not sure of what you're doing on your calculator. So put in your y1, put in your y2, find the intersection. So this is my y1, this is my y2. The biggest thing on your calculator is your windows. And the X is the thousands of tons of product. So this is product. And the Y ends up to be total cost or revenue. I'm going to leave that blank for now until I get through this problem. So if I look at my calculator, my plot is on, I need to take that off. And if there's anything in your y1 or your y2, you definitely want to take that out. You don't want to just type over it in case your new equation is smaller. You'll end up with some extra things on there that won't work very well for you. So 61, 740 plus 440x. And the next thing I need to do is figure out my window. So let's go into the window. And let's just do a zoom 6 just to see what's going on here. We can't really see anything, but it kind of restabilizes our graph for us. Nothing's on there, just that one line. I'm going to start at 0. The X represents the tons of thousands of pounds. I'm going to go to 50. I'm just picking that number. I don't know if that's going to work or not. And my Y minimum, I'm going to start at 0. And if I look at the Y-intercept, ends up to be like 61,000. So I'm going to just go big on that. So if you look at this Y-intercept right here, that's 61,000. So my window on my Y, I'm going to make it, 70,000. Actually, I'm going to go to 80,000. Let's just see what happens on that one. And I can see the intersection. So I need to know what is the X and Y that make these equal. So one's the cost and one's the revenue. When are they equal? That's going to tell us our break-even point. So I'm going to calculate the intersection, which is number 5. And I'm going to let my smart bug just hop. And my intersection is 12 and 67,020. So I'm going to go back to my sheet here. And I'm going to put in 12. Actually, I have my graph over here. And 67,020. So I'm going to fill this in now. This is going to be my cost and revenue. Because if you notice, when you plug in your X here and here, it's going to kick out your revenue and your cost, and that should be the same number, which it is 67,020. So when my, if I was going to explain this, find the number of thousands of tons of product that gives a break even, this is what I'm going to write. I'm going to say the company will break even if 12, and I could say 12,000 tons, or I'm going to put 12,000 tons are sold, and the cost and revenue are both $67,020, which will make a profit of $0. So that's a good way to show both of those. If I had you write a sentence on your test, you would definitely want to include both of these numbers with respect. Notice that both those numbers are in here, and that shouldn't have a dollar sign on it. With respect to this problem, so be really comfortable with making a sentence. And if you forgot one thing, like I would also have that in there. If you're forgetting something, you won't get all the credit on this. So really try to work at doing one sentence with all the information in it. Okay, work to be shown on homework and quizzes and tests. So you want to have what the X and Y mean, like we did right here. The X and Y meant. You want the original equations. So looking at back at this one here, I have the original equations here and how they what the relationship to each other is. You want to have your equations to be graphed. So that's going to come up in the next problem where we actually have a different equation we're graphing. We want the graph, we want the windows, the intersection, and then answering the question. And the only thing I didn't put on here was my window, which I believe was 0 to 50 and 0 to 80,000. 0 to 80,000. When you're dealing with really big numbers, please put commas in there for me so I don't have to count all those zeros. And that is the work that I'm looking for. It'll be reproduced on our test, so do them in your homework so you get really good at it. Investment problem. An investor has $300,000 to invest. Part at 12%. So this is going to be the total amount to invest as I break this problem down. Part at 12%, and the remainder in a less risky investment at 7%. So this one's less risky. If her investment goal is to have an annual income of $27,000, how much should she put in each investment? Okay, so the first thing I need to do is figure out, and the goal is how much will she put in each investment. So amount in the 12% investment is going to be my X, and the amount to put in the 7%, the less risky investment, is going to go there. So there's my variables. Definitely want to know what we're doing here. That's going to give us a lot of clarity. So this is going to be my X and my Y. So I want to make a total investment of $300,000. So whatever I put in my X plus however much I put in my Y is going to equal my $300,000. So this has to do with the amount. This has to do with what I'm going to make, the annual income. So if I make 12%, I'm going to change that to a decimal, of the X amount, however much, I could put 100,000 and 200,000, or I could put 150,000, 150,000. I don't know what these are. But however much I put in my X, I'm going to make 12% on it. Plus, however much I put in my Y, I'm going to make 7%. So 7% of whatever I put in my Y. And that's going to give me my total profit of $27,000. So here's my two equations, two unknown. And again, remember, we're not going to follow the book on these. We're going to solve these through our graphing calculator, which you will probably appreciate. So when I go back to the screen here, it says equations to be graphed. In this case, I have to convert my equations because I can't put that in my y1 and my y2 unless they're solved for y1, y2. So what you're going to do is you're going to solve these for y. So I'm going to move the x over. So y equals negative x plus 300,000. That's going to be my y1. And my y2, I'm going to move this x over, and then I'm going to divide by that 0.07. So I'm going to start with my 27,000. I'm going to minus my 0.12x, my x term. You're going to do these all the same. That's why I'm going to do a little shortcut here. If you need to show all your work, show it. I'm going to move the x term over, and then I'm going to divide the whole thing by 0.07, and that's going to get the y by itself. When you put this in your calculator, be sure that you put parentheses around that numerator because you're subtracting. Now you're going to go to your calculator and you're going to put this in, and then we need to find my windows. And being these are hundreds of thousands and they go up to 300,000, I'm going to let my X window be 0 to, and my Y window to be the same, 500,000. I'm in the hundreds of thousands. I'm just going to go a little bigger than what's there. And then my goal here is to find how much is going into my X and how much is going into my Y. So how much money am I putting into the 12% investment, and how much money am I putting into the 7% investment? So I'm going to go to my calculator next. I'm going to go up to my Y equals. I'm going to clear these out. And then I'm going to go ahead and put in what I have here. So I have 300,000. Make sure your zeros are right. That's a very common mistake. I even make it, that you have enough zeros to make your 300,000. And then I'm going to put parenthesis. Make sure you use the negative, not the subtraction, or it'll give you an error. So negative 0.12x plus 27,000. We did it the other way. Let me clear that out. Just reading my notes here. We did 27,000 minus 0.12x, it doesn't matter, they're both the same, parenthesis, divided by 0.07. And then we changed our window again from 0 to 500,000. Again, make sure you're putting the amount of zeros in here that you need. I need one more. So make sure you're counting that. They don't have they don't have commas in them. 1, 2, 3. And then I'm going to graph that. And if I don't see the intersection, I need to change my window. And in my case, I do. So I'm going to calculate the intersection. I'm going to let my smart bug do the hopping here for me. And I end up with 120,000 and 180,000. So I need to go back to my paper here. And I'm going to let this is going to be my Y2. So this is the work you're going to show now. You did all the work on your calculator, really. Y1, here's my intersection. Even if I don't use both these numbers, remember on your intersection, to get all the credit, you need to have the ordered pair that you got on your graph. It's proving to me that you graphed it. And remember, the first one was the 12%, and the second one was the 7%. So make sure you don't switch these around or you're going to lose credit. So if I go back, down here, I'm going to say that it's going to be 120,000. I'm going to put in the 12%, and 180,000. I'm going to put in the 7%, and that is going to create my profit of 27,000. So if I were to plug both those in there, I should end up with 27,000, and I should end up, if I add them together, the 300,000. Medicine problem. A nurse has 2 solutions that contain different concentrations of a certain medication. One is a 12% concentration, so that's going to be the number of cc's, which is cubic centimeters. So this is the amount of cc's of the 12% concentration. And the second one is going to be the amount of cc's of the 8% concentration. How many of the cc's should she mix together to obtain 20 cc's? So I want to make a total of 20 cc's at 9%. So the first thing I'm going to do is I'm going to say, so this is my X, this is my Y. however much of the 20 cc's plus however much of the other concentration has to make 20 cc's. So if I did 10 and 10 or 5 and 15, I don't know, but they have to add up to 20 cc's because that's all I'm putting in. The second part has to do with the concentration. So at the 12% concentration, I need to know how much of the solution I want to put in there. Plus I need, out of the 8%, how much of that is going to give me a 9% of the 20 cc's. So I want it to be a 9% mix. I'm going to put so much in my 12%, so much in my 8% to get my 20 cc's of my 9%. So these are my original equations. A lot of points in these problems. You're going to get credit for all of this. Now I cannot put that in my graphing calculator right now because I need to convert to y equals. So I'm going to move this x over again. So I'm going to have 20, whatever was originally there, and I'm going to subtract x. And then I need to move over the x term and then divide by this 0.08. So I'm going to put this, I don't need to do any of the math. In fact, I prefer you just to leave this because I don't want you to make any silly mistakes in doing that, and you waste time. And your test is time. So just leave it like that. Your calculator will handle that. So I'm going to subtract this x term just like I did in the first one. And then I'm going to divide the whole thing by my 0.08. And again, I want to put parentheses around that top part there. So I'm going to put both those into my graphing calculator. I'm going to come out with my equations there. And then I'm going to find my intersection. And I'm trying to find how many cc's of the 12% solution and how many cc's, and make sure you don't mix these up. That's why we have that ordered pair up there, so you don't mix them up, of the 8% solution. So I'm going to go to my graphing calculator again. I'm going to go into my y equal. Again, don't take any shortcuts. You want to do this because you want to be very fluent and quick on your calculator. So I've got the x minus 20. And then on this one, be careful that you put your parentheses in there. So I've got my 0.09 times 20 minus my 0.12x parenthesis divided by my 0.08. And these are pretty small numbers if you look at them. You know, the 20 is the negative 20 is, or actually I did that one wrong, I think. This should be, clear that out. This should be 20 minus x. Okay, so I'm going to go into my window, and I'm not going to have any negatives again, so I'm not going to worry about that, but I'm just going to go out to, let's go to 50, a little bit more than our numbers. I just need to find the intersection, right? There it is. So I'm going to calculate. Never use the trace button. I'm going to use the calculate button only. The intersection, never use the trace button. Students that do that don't get exact answers and they lose all their points. So please be sure you're using the right buttons. And that ends up to be 5 and 15, the 5 being the 12% and the 15 being the 8%. How do I know that? So this is going to be 5 and 15 because it shows right here. There's my ordered pair, so I know which one goes where. So this is going to be 5 cc's of the 12% solution and 15 cc's of the 8% solution will give me my 20 cc's and will also give me that 9% solution that I'm looking for. Those are your notes. And here is your homework. Again, you should be spending quality time on this. this video plus you have another hour, that's an hour and a half, 90 minutes a day. So you should be spending, pretty much an hour on your homework. And then I just have a list of here of what I'm looking for again on your homework.